Alright everybody, welcome to this class, and in this class we are going to continue solving more problems on electrostatics. And in this we are going to be solving the exercise here, and in this exercise is start from exercise 1.1, right? Exercise 1.1, 1.1. And in this exercise 1.1, it says, what is the magnitude of the Coulombic force, I getting it now, between two-point charge of values Q1 equal to plus 3.00 microcoulomb and Q2 equal to plus 5 plus 00 microcoulomb, separated from each other by a distance, arrow here is equals to 30 cm in free space. And what is the nature of the charge? In this case now, we are going to be using the Coulomb's law, which says that F is equal to what? Q1, Q2 over R squared. And the force is what we're looking for. So this is a direct substitution. And K, we already know the value for K is 9.0 times 10 raised to power 9 times Q1, ignoring the sign, is 3 times 10 raised to power minus 6, right? Times 5 times 10 raised to power minus 6. Everything over r square, and r is 30 cm, that's same thing as 0.30 square. So when we evaluate this on our calculator as 1.5 Newton. So what is the nature of the force? I told you like terms attract and unlike terms repel. So the sign here is plus and the sign here is plus. So what will plus and plus do? Plus and plus and like terms, and they will do what? They will attract, they will repel, sorry. So our next exercise is exercise 1.2. It says determine the electrostatic force between two equal charge of 5 microcoulomb separated. So it means that the two charges have 5 microcoulomb. It's very easy. K, Q1, Q2 over R squared. So in this case now, our K is 9.0 times 10 raised to power 9, right? And Q1 and Q2 are equal, so when they multiply, it will be squared here. Then we already know that the charge there is 5 microcoulomb, so that is 5 times 10 raised to power minus 6, right? All over the distance of their separation. And the distance of their separation is 5 cm, which is simply as 0.05 square. So when you evaluate this in your calculator, you have F to be equal to 90 Newton. Are we getting it now? So let's go to the next one, which is example 1.3. Example 1.3. So example 1.3, what does this say? It's very easy. Example 1.3 here says that how far does the electron of a hydrogen atom have to move from the nucleus for the force of attraction in the electron to be equal to the weight at the Earth's surface. This is very easy. It says how far does it have to move for the force of attraction, the force. What force is that? Electrostatic force. So in this case now, how we are equating the electrostatic force Fa into what? The gravitational force, that is F, or let's say Fg. And we know that the force of gravity is the weight, right? So Fg here is same thing as the weight, and weight is given as mg, right? Now, what of Fa? Fa is electrostatic force, is given by K Q1, Q2 all over r square. So what we just need to do is that we equate both of them together. Since Fg is equal to Fe. So that means from here, Mg is equal to K Q1 Q2 all over r square. Then we'll make our arrow the subject of formula. That will be K Q1 Q2 over Mg. And when we remove the square from here, it becomes what? Square root. So this place becomes, when the square goes to the other side, it becomes the square root here. So arrow is equal to the square root of what is K? K is 9, right? Times 10 raised to power 9 times what is Q1? Q1 is the charge of an electron. Remember that the proton is positively charged and the electron is negatively charged, but both of them have the same magnitude. So that is 1.6, right? Times 10 raised to power 19. So since Q1 and Q2, I'm getting it now. Since they are equal, I don't really need to say times 1 point again. I just need to square. That's just what I need to do. All over. This M here is the mass of the proton, right? Sorry, it's the mass of the electron because we are talking about an electron here. How far does the electron? So the mass of the electron is same thing as 9.1094 times 10 raised to power minus 31 times our G is the gravitational acceleration, that is 9.81, right? So when you evaluate this in your calculator, you will have an answer that is approximately equal to 5.03 meter. All right, so let's go to the next question here. And the next question here says that two pairs, that is 1.4, example 1.4 here, says two spheres placed 30 cm apart have equal charges, right? How many excess electrons must be present on each sphere if they experience a repulsive force of 2.30 times 10 raised to the power 22 Newton? Assume free space between them. So what we do here is that they say two spheres, right, that have equal charge. And really though, anywhere you hear equal charge, just use Q square, right? So in this case now, what are they trying to say? They say how many excess electron, but you cannot get the number of electron. That's they are looking for number of electron, right? And to get the number of electron, we use this formula Q is equal to Ne. But where do we get the Q here? We get the Q from F to be equal to what? K Q1 Q2 all over r square. And in this case now, this becomes K is equal to our Q1 and Q2 are equal, that become Q square over r square, right? Making this Q subject of formula, that becomes F r square all over K, right? All in square roots. Is that true? Yes, if that is true, that becomes something like this. What is our F? Our F has been given to us as our F was given in the question as 2.30 times 10 raised to the power minus 22. So that's 2.30 times 10 raised to the power minus 22 times our arrow square. So square this. So what is there is they say 30 cm apart, right? So that is 0.3 all over K. And we know that K for free space is 9 times 10 raised to power 9. So if you evaluate this in your calculator, what will you have? If you evaluate this in your calculator, what will you have? So that should give you 2.30 times 10 raised to power minus 22, right? Is it not? Times 0.3 square, right? All over 9 times 10 raised to power 9. So that will give you 4.7 or 4.8 times 10 raised to power minus 17. So you have 4.8. So in this case now, this is same thing as 4.8, right, times 10 raised to power minus 17. So using n to be equal to q over a, so our q is 4.8 times 10 raised to power minus 17 all over our a is 1.6 times 10 raised to power minus 19. When you evaluate this, we have n to be equal to 300 electrons. So on to the next. So in this question, it says three charges Q1, right, Q2 and Q3. They gave the coordinate. The coordinate of Q1 is 0, 0, right? So that is 0, 0. And where the 0, 0 is, that is be at the origin. So let's say that Q1 is here. Then Q2 is, they say Q2 is at 0, 10. We already know that this is x-axis and this is what? Y-axis. So 10 from the y-axis, this should be, right? Q2, 10. Right? Then Q3 should be, Q3 here, say Q3, that is 15, 0. This is x and this is y. So that means 15. And this 15 is not having minus, so it will be at the positive x-axis, and the x-axis is already on the horizontal, so that will be Q3, right? You know, this will be 15. Yeah, and it means minus 15 would have gone to this side. So you can do like this, but it's not needed. All right, so say the first question is find the total electric force at 0, 0. So we mean that we are finding total electric force on Q1. To do this, what do we need to do? To do this, to find, what we just need to do is we find the force of Q1 to this place and the force of Q3 to this place. First, let's find the force of Q2 to Q1. Force of Q2 to Q1 is given by, remember that F is equal to K Q1 Q2 over R square, right? So in this case now, our K is 9 times 10 raised to power 9. Our Q1 is this Q1 here, and it's given by the value minus 2, that is 2 times 10 raised to power minus 6, right? Then our Q2 is given by the value, right, 4 times 10 raised to power minus 6. All over, what is the distance of separation? 10 cm, right? So that will be 0.1 square. And if you do that, you will have an answer like 7.2 Newton. Now, this 7.2 Newton in component form, since it's towards the x-axis under vectors, sorry, toward the y-axis under vectors, it's also called J component. So this will be J, right? And now you see that this Q2 is positive and this Q1 is negative. So what will they do? They will attract, right? So the force on this now will be like it will be taking Q, it will be pushing, attracting Q to each side, right? So it's along the positive axis, right? The force is attractive, taking Q1 to this side, attracting Q1 to each side. So it's a positive force. So how about the force that Q3 exerts on Q1? The same thing. Using F is equals to KQ1 Q2 over R square. Our Q1 is the same Q1, right? Which is equal like to change my pen to white, which is equal to, we know our case always 9 times 10 raised to power 9 for air, times our Q1 is 2. We ignore the sign, that is 2 times 10 raised to power minus 6, times our Q3 is 4, right? That is 4 times 10 raised to power minus 6, all over arrow square. So what is our arrow here? Arrow is the distance of separation. The distance between Q3 and Q2 is 15 cm. Converting 15 cm to meter, that becomes 0.15 meter, right? All square. When you evaluate this in your calculator, we have a value as 2.4 Newton. But if we want to consider this in sign, we see that this Q1 is plus, right, 2 microcoulomb. And this Q3 is minus 3 microcoulomb. So what will be happening here? Attraction or repulsion? Obviously, it will be what? Repulsion, right? Because they are like charges. So it means that the force of Q3 on Q2 will be repulsing it, like bouncing it back. And if repulsion is happening on Q1, where will Q1 be going? Will Q1 be going here? No, because it cannot attract to this side. Q1 will be going to the other side, which is this side, right? Because Q1 will be pushing to this side, and Q2 also will be pushing to this side. Like it will be repulsing each other. This one will go to this side, this one will go to this side. Now, observe where Q1 will go to. Where will Q1 go to? The negative, right? Yes, the negative x-axis, right? Because these are origin, positive x-axis, negative x-axis. So we can say that our force is, that is when we want to put the direction, but it's not needed, but that is minus 2.4 Newton, right? Depend on how you see it in exam. If you see sign in your option, then you consider it, right? So in total, we already know, so in total, the force on the origin, that is the force on Q1, is minus, right, 2.4 Newton. Yeah, because we consider x before y. So that minus 2.4 Newton I plus 7.2 Newton J. Right? Alright, so what's this next answer? Next question. Option B says find the magnitude of the total force. That's very easy. To get the magnitude of the total force, that will be F. Remember the law of vector is equal to what? Right? 2.4 square minus 2.4 square plus 7.2 square. And that is going to give you an answer like 7.6 Newton. And option C here says that, what does option C talk about? Option C says, what is the angle that the force is very easy. Still try to talk about direction. To do this, what do we do? Everything here is just vector. The law of physics is still remain, right? So recall that tan theta from vector algebra is equal to Fy over Fx, right? So that means that theta is equal to tan inverse of what? Fy over Fx, right? Yeah, so our Fy here, so that means the tan inverse. What's our Fy? Our Fy, let me make it more clearer. So that is tan, you press it in your calculator. Our Fy here is 7.2 and this is minus 2.4. If you press that in your calculator, you will have a value like, if you press that in your calculator, you have a value like this, minus 71.565. So what do you do? Using our trig identity, we already know this. You just add it to 180. That is 180, right, plus minus 71.565. And you are going to have an answer like 108 degree. Thank you very much for watching. God bless you. Make sure you like, share, and subscribe. Thank you very much.